I am Matthew Manuel from Goodard School, ISC 2022, and here I am to present before you my physics project titled Finding the Relationship Between Refractive Index and Concentration of a Solution. Refraction is the bending of light when it passes from one medium to another. Refraction depends on various factors such as temperature, density of the medium, and etc. Refraction is greatly influenced by optical density. Optical density is the measure of absorbance of a liquid. Optical density is greatly influenced by the concentration of a liquid. In my project, we aim to find the relationship between the refractive index, which is in turn influenced by the optical density, which in turn is influenced by the concentration of the solution. Let us begin with our experiment. First, let us see the apparatus required. Apparatus required for the experiment: a spectrometer, a mercury source light, a hollow prism, different concentrations of potassium permanganate, and finally a magnifying glass. The spectrometer consists of four major parts: a telescope, a prism table, a collimator, and a vernier scale. Initial adjustments of a spectrometer. The telescope is adjusted in such a manner by focusing it on a distant object. The prism table is adjusted by using a mercury level. The collimator is adjusted using the screw to render a parallel beam of light. Directory measurements are done to make sure that the vernier 1 and vernier 2 are set at 0, 180. It is done so by making sure that the light from the narrow slit in the collimator falls in the telescope such that the crosswire is placed exactly on the narrow slit. Directory measurements are followed by finding the angle of the prism used, for which the empty hollow prism is placed on the prism table. The parallel beam of light from the collimator falls on the prism and it is reflected. The reflected ray is viewed through the telescope. Once it is observed, the telescope is fixed and the vernier 1 and vernier 2 readings are noted. The same is repeated for the other face of the prism. Find the minimum deviation of the prism. The prism table is moved in one direction. It is then observed that the slit also moves back and forth. At one point, the slit remains stationary. That point is called as a turning point. To find the turning point, the prism table and telescope are moved simultaneously. Once the slit is observed, the telescope is fixed and the vernier 1 and vernier 2 readings are noted. This process is repeated for different concentrations of potassium permanganate solution. Using the minimum deviation obtained, we can find the refractive index.